guys, welcome to our channel of Sciences and Mathematics. Today's topic of discussion will be a topic in volumetric analysis. That's a chemistry topic, of course, and it's going to be on the mole fraction. The mole fraction is a convenient way of trying to express the concentration of a solution, of course, and which is a convenient way because it is independent of temperature and the phase density of a substance. In this way, we're going to see that there are different ways in which we can be able to express the concentration of a solution. And one of the ways is using the mole fraction. So I welcome you to the discussion. So in that case, we are going to learn about this concept of volumetric analysis, of trying to find out one of the ways in which concentration of solutions or maybe reacting components can be able to be expressed. And that is on the mole fraction. The mole fraction. So as I've said, mole fraction refers to the it's basically a method in which we are going to use to try to describe the number of moles of a solute as a fraction of the total number of moles in a mixture. So that's basically a definition for this mole fraction. As we have said, is one of the methods that is used to describe a concentration of a solution, and therefore, as we have said, it refers to the moles of a solute as a fraction so that's a ratio as a fraction of the total moles in a mixture. So in this case, whenever we have maybe two reacting species or just a mixture of a species, this concept of a mole fraction is useful to describe the number of moles or the volumes when these two reactive components are mixed together. Now, suppose we have a solution that is containing, maybe this is a solution. We can just demonstrate it using this. Maybe this is a solution that is containing, of course, the moles of substance A, B, and C. Now, in this case, to express the mole fraction of a substance, one of the components of this particular solution, like we said that we have component A that is making up this solution, we're going to express the mole fraction of that component A as the number of moles of A divided by the total number of moles in the mixture. So that is over the number of moles of A plus the number of moles of B plus the number of moles of C. So this basically is a general way in which we can be able to define this concept of a mole fraction. I'm going to use an example or an equation or just a question to try and figure out how we can be able to calculate the mole fraction given different quantities of a substance in a mixture. So I'm going to write a question here so that we can be able to use it in order to do or illustrate that concept. And for this case, we are given this question whereby we are supposed to determine the mole fraction of each of the components of a mixture that is made up of methyl alcohol, ethyl alcohol, and water. So therefore, in this case, of course, we are going to apply the general formula that I've written on the board, or the previous general formula I've already written on the board, to find the mole fraction for each of the components for methyl alcohol, ethyl alcohol, and water. So I'm going to divide this table into three specific parts for each of the components. So therefore, the first one I'm going to have is methyl alcohol, and the second one I'm going to have is ethyl alcohol, and the last one that I'm going to have is water. So this is for A, B, and C respectively. So therefore, I'm going to use that general formula to try and find out the mole fraction for ethyl alcohol, the methyl alcohol. So in this case, the mole fraction is given by X of methyl alcohol is the same as the number of moles of methyl alcohol divided by the number of moles of ethyl alcohol plus number of moles of methyl alcohol plus number of moles of water. So therefore, we're going to extract this information from the statements we have been given. The number of moles of methyl alcohol is 2.9. 2.9 divided by, so the other figures, I'm just going to write them here now that we have been given the exact figures in the question, 7.2. This is going to give us a 0.2117 for methyl alcohol. So similarly for the mole fraction for ethyl alcohol, it's going to be Xe, that is for ethyl alcohol, which is the number of moles for ethyl alcohol plus the number of methyl plus number of for water. This is going to give us a 3.6 over 13.7, which of course is going to give us 0.263. And the last one, the number of moles for, the fraction, that is the mole fraction for water. It's the number of moles for water divided by the number of moles, of course, for ethyl alcohol, number of moles for methyl alcohol, plus number of moles for water. So therefore, this is going to give us a total of 0.526. And as we can see, for a complete fraction, it has to be made a ratio that is a total ratio gives us a total of 1. So we can just add the figures across to confirm whether that makes the correct percentages. The totality of that, whether it makes the correct percentages of 100. But this is the way in which we are going to use this formula in order to find the mole fraction as a way of expressing concentration over the individual components of a solution. So as I've said, this method is convenient because it's, number one, it's a way in which we can be able to express concentration. Number two, it is independent of temperature and phase density of a substance. So in this case, of course, this is one of the strategies or methods that we're going to use in volumetric analysis in trying to express different or concentrations of different solutions. So that is it for today, guys. I hope that this concept has been understood and we're going to apply it appropriately as it may be needed. So thank you. Bye. God bless you.